Welcome to Probability and Statistics. In this lecture video 7.1, we're going to talk about one of the most important theorem in this course, which is called the central limit theorem. Here's the concept, and I'm going to refer back to at the very beginning of our course just in a minute. The simple mean, which as you can recall is called x bar. The simple mean x bar can be used to approximate the population mean mu, since it is easier to obtain the simple mean. So as you can recall, our very first lecture video, when we first getting started on your handout, this concept that I wrote, the whole course is really about analyzing the data of a population. So instead of collecting the data from the entire population, which is almost impossible, we can take many small samples of the population. So based on the sample that we collected, we can actually analyzing the true parameter of the population. So if we're gonna start taking lots and lots of samples, different samples from the population, what we're gonna end up is different simple mean. Okay, that's kind of weird concept, because just think about this. When we talk about, when I use the example of a median household income, all right, of United States, the standard the cost of living is very different between certain states in the north versus the southern states. So when we take a simple mean of certain region in the southern states compared to the northern region, the bigger city, of course the median household income, the simple mean, will be different. So if we take different sample from population, we're actually going to end up with different simple mean. So let's pretend this entire rectangle is my population size n. Okay, this is my whole population. So if I can take a sample here, take a sample here, if I can take lots and lots of sample, eventually I will actually include my entire population. That's the whole idea. If I take bunch and bunch samples, everywhere I take these samples, okay, eventually it will cover the whole. Eventually I will basically have as many people as I can have, okay, from the population. So different sample is going to have a different simple mean. Okay, so because I know I will have different simple mean, then the simple mean will actually become a random variable. Okay, it will actually become, your simple mean will actually eventually become a type of variable based on all the different randomness. Okay, all the different samples everywhere in the population. Okay, so all these x bars will become our random variable. So this thing called the sampling distribution of the simple mean. Okay, this is a type of distribution based off your all your simple means. Sampling distribution of the simple mean x bar is a probability distribution using x bar as a random variable, with the mean called the mu of the x bar, and the standard deviation is, the standard deviation will be called the sigma of the x bar. So the central limit theorem says, for any given population with the mean mu and the standard deviation, a sampling distribution of simple means will have the following three characteristics. If the sample size n is at least 30, okay, that's our magic number. Our sample size got to be 30 and greater, or the population is normally distributed. So the central limit theorem says, if I have sample size greater than or equal to 30, or population is normally distributed, then the mean of a sampling distribution of the simple mean is called mu of x bar, which will eventually equal to the mean of the population. Okay, that's very important concept, because as I taking all these samples, they're all gonna have different sample mean. So eventually, once I have all these sample mean, then the mean of all these sample mean will eventually be the mean of the population. Okay, that's what we're trying to do. Take lots and lots of samples. So eventually, the mean of all those sample means will become the population mean. The standard deviation of the sampling distribution of the sample means, sigma of x bar, will equal to the standard deviation of population divided by the square root of the sample size. So the standard deviation of the x bar is going to be the population standard deviation divided by square root of your sample size. Okay. So this is a little bit different. The shape of a sampling distribution of sample mean will approach that of a normal distribution. Very important concept. Regardless the shape of the population distribution. The larger the sample size, the better the normal distribution approximation will be. So eventually, the shape of a sampling distribution will become your bell curve shape, the normal distribution. Okay. So, since we are making sample mean x bar as a random variable from a population, with a population mean mu and standard deviation sigma, it makes sense. Okay, it makes sense. The mean of the sampling distribution x bar will become the population mean. The sigma of the standard deviation of the sampling distribution will be the sigma of the population divided by square root of n, and that is called the standard error to the mean. So if the random variable x is normally distributed, then the distribution of x bar will also be normally distributed. So if my population is normally distributed, okay, then my sampling distribution will also be normally distributed as well. Now, what the central limit theorem also says is, if my sampling distribution is normally distributed, okay, regardless the shape of the actual population curve, eventually if I take my sample large enough, alright, if I take bunch samples, eventually my population will also be normally distributed. Okay, so there's one little thing I want you to recognize. The different color coding here also helps students to realize the sampling distribution, this normal curve, is a little bit tighter because the standard deviation is not as wide spread out. For example, the standard deviation is 15 for the population, but the standard deviation of the sampling distribution is taking the 15 divided by the square root of 9, which, as you can see, that's 15 divided by 3, which is 5. So what the mean is, one standard deviation to the right is just plus 5, plus 5, plus 5. For the population is plus 15, plus 15, plus 15. So that's the reason why this pink graph looks a lot higher, because it's a little bit tighter graph. Okay, as far as left and right, it's a little bit tighter. Alright, so keep these formulas in mind. We will need them. Okay, we will need them when we start talking about how to find the standard score for your sampling mean. Alright, but be very careful when we head to lecture video 7.2. There are problems, okay, where we are still using the regular z-score that we learned before. Okay, there are some problems still using this formula. Okay, but there are some problem if it's talking about the sampling distribution, then we got to turn to these formula. All right. So let me go ahead and show you real quick. Chapter 7. Okay, the formulas is on here, and we'll talk about the standard score in the next lecture video. Thank you for watching.